I'm not sure I'm seeing. Everything clearly. There was a little blurriness there. Okay, so we're going to solve this system. Now, as we know from last time, we can write the system. I'm going to write it up here as an augmented matrix. Everybody did this with brackets. Some people actually wrote out 5x, 3y equal the 9 and stuff. And that's pretty harmless, but it's more efficient to just leave the x, y and equal signs off and use the augmented matrix. Also, there are computer systems, computer algebra systems that would want the augmented matrix, okay? And they just do it for you automatically. You do the augmented matrix, they simplify it, and boom, there it is. Okay, so that's very handy. But first we got to learn what's going on, and I think we're doing a pretty good job of that. Okay, so I'm going to call this row 1. I'm going to call this row 2. And that's it. I don't do anything to row 1 or row 2 in this step. I come down to the next step. And yes, I'll do the details. Okay, if I multiply row 1 by -6 and row 2 by 5, I get -30, 18, -27. Here I get 30, 20, and 130. Now you might have multiplied this one by 6 and this one by -5, in which case you would have had -30, -20. And -130 anyhow. So I do the -6 times 1 here where I do it. I don't do it up here. I do it when I get to this row. And remember that row 1 and row 2 always refer to row 1 and row 2 of the previous step. Okay. So then I do like this. You write row 1, -30, 18, -27. And then row 1 plus row 2, -30 and 30 gives me 0. 18 and 28 gives me 38. And -27 or 130 gives me 103. And that's bad because I only got half of what I should. This should be -54. -54 and 130 is 76. Okay. I don't know where I got the 27. I think I saw the 3 and the 9 and multiplied it. You got to be careful and do it more carefully than I do. Okay. And that's not a -50. Yeah, it is a -50. Okay. Now, at this stage, I can divide row 2 by 38. I get -30, 18, -27, 0, 1, 2, which tells me that y equals 2, as we saw last time. Okay. Now, I can continue. I can do row 1 plus 18 times row 2. And notice that I'm not going to actually multiply row 2 by 18 because row 2 already gives me my solution for y. So I just look at my numbers. 18 times 0 is 0, add that to negative 30, then I have negative 30. 18 times 1, and that should be minus 18 times row 2. Again, very easy to make sign errors. I've made several this morning already. Not a real good day for sign errors, but and we do minus 18 times the row 2. Minus 18 times 1 is negative 18. Add that to 18, I get 0. Negative 18 times 2 is negative 36. Negative 36 and negative 27 is negative 63, which means this is negative 54. This is negative 54. And this is negative 70. 36 and 54 is 90. Yeah. Now I see I'm pretending to make all these mistakes so you understand it's a lot easier to do things carefully first time and write it out carefully. Anyhow, so again, the point is, what I'm doing here is I'm noticing that I've got a 1 here. I want to get rid of the y in this thing, the 18. So if I multiply 1 by negative 18 and add it to 18, I'm going to get 0, which is what I'm after. Okay. Then, of course, I've got to multiply everything in this row by negative 18, add it to the first row, and here's what I finally get after I subtract my errors. Okay, so we get this. Well, I'm going to bring this on up. And I'm just going to rewrite it. So and then, of course, we retain row 2. So again, this is 1 minus 18 times row 2. And this is row 2. Just repeating this matrix, not doing anything new. And now I'm going to take row 1 and divide it by negative 30. And row 2, once I get row 2 into this form, I never mess with it. I just use it. Okay, row 1 divided by negative 30 gives me 103. Row 2 gives me 012. Row 1 then tells me that 1x equals 3. There's no y, so I get x equals 3. Row 2 tells me y equals 2. Then I can check that back in the original equation. Now, I'm not going to write that out just for purposes of time, but you should do this. You know, we replace x by 3, we replace y by 2. We get 15 times 3, and 5 times 3 is 15. 3 times 2 is 6. 15 minus 6 is 9. Replace x and y again by 3. 6 times 3 is 18. 4 times 2 is 8. 18 and 8 gives us 26. And we check. Now, I did that with my pointing and I did it in my head because the numbers are easy. But you usually will want to write that out, especially in the test, once they do this and check. You say, okay, I checked in my head. And then I check and find out that you're wrong. Okay, and that I penalize that pretty hard. But just for your own sake, if you check these as you will go, you find your own mistakes and you learn faster if you find your own mistakes than if Open Math finds it. Okay, or I find it. All right, now I'm going to do this again because there's a little more perfect way to do it. You notice down here, I did row 1 minus 18 times row 2. Okay, I never multiplied row 2 by 18 and put it into the matrix. I might have done that in a calculation off to the side someplace, but not in the flow of the matrix reduction. And yeah, okay, I can see one. Okay, so I'm going to get start. This way. And here I'm going to do okay, instead of actually multiplying row 1 by -6 and row 2 by 5, or row 1 by 6 and row 2 by -5, which would work equally well. I'm just going to say, I'm going to do -6 times row 1 plus 5 times row 2. I'm just going to do it all in one calculation. And when I do that, I'm going to get, well, look at it, -6 times 5 is -30. 5 times 6, okay. -6 times row 1, 5 times row 2. -6 times 5 is -30. 5 times 6 is 30. And continuing my propensity for doing things carefully. That was negative. You want to put that in row 2. Row 1, I don't want this. Okay, so if I do that again, in the first place for this row, I'm going to get 0. -6 times -3 is 18. 5 times 4 is 12. And that's going to give me 30. -6 will give me 38. Okay. -6 times 9 is -54. 5 times 26 is 130. I add those up, I get 76. 130 minus 56. Okay. Row 1 is just row 1, so I write row 1 down here. And down. I'm going to run row 1 again. And I'm going to do row 2 divided by 38, giving me 5, -3, 9, 0, 1, 2. All right. Now I've got my solution for y. So y is going to equal 2. If I can get rid of this -3, I'll have my solution for x. I'll have a something 5, 0, something. Okay. Let's see how that works. Well, if I add 3 times row 2 to row 1, that's going to work out because 3 times 1 gives me 3. Add that to -3, I'm going to get 0. Okay, so starting here, row 1 has 5, row 2 has 0. So we're going to do row 1, 5, plus 3 times row 2, 0. 5 plus 3 times 0 is still 5. Okay, now 3 times row 2 here gives us -1 and -3. Add that to row 1, which is 3, we get 0. And then 3 times the row 2 number is 3 times 2, 6. We add that to the row 1 number, 9. we get 15. Then we do row 1 divided by 5, and row 2. Got to squeeze it in here. You get 1, 0, 3, 0, 1, 2. Same solution. That we ended up with over here where we still can't quite see it. Let's see. All that into the screen. Okay. And yeah. Okay. We end up with the same matrix we had over here. This matrix are the same because all the steps were valid. Okay. The difference is that we never actually multiplied 6 by row 1 and wrote it out as a row. Okay. We just incorporated it by doing -6 times row 1 plus 5 times row 2. Now we could have written that off to the side. Okay. So this calculation, -6 times row 1 would be -30, 18, -27. And 5 times row 2 would have been 0. Sorry. 5 times this row 2 would have been 30, 20, 130. And I keep wanting to write 27 there. Where am I getting 27? It's stuck in my head somehow because it's nowhere on the board now. It was there. Anyhow, this would be -54. Okay, when we add these up, we get 0, 38, 76. So that's what we put here. Okay, so when you do a multiple of one row and a plus or minus a multiple of another row, it's okay, leave yourself room in the margins to write out the calculation, but don't do it in the system of matrices because you get a lot of numbers you don't need. Okay, we had to deal with the -30 here, okay? Now, it's not much harder to deal with a -30 to 5, but the other thing is, it took us 2 steps to get from here to here. In one step, we get from here to here. And this is equally simple with this, even actually a little simpler because the numbers in the first row are smaller. But the key is we get the 38, 0, 38, 76 row. That's how we start. Okay. Makes sense? So think of the most efficient way to do it. And typically, we're going to do calculations like this. Write them out off to the side. Keep yourself straight. Okay. What we're going to do same stuff on a 3 by 3 matrix. Okay, here's a system. Can you write that system as a matrix? Okay, you've asked to solve this system. I ask everybody then to write this as a matrix equation. Now you, and some of you have because you're in the support course, but most of you haven't because you haven't gotten systems of three equations unless you've seen it in previous courses, which I think is unlikely, but not impossible. But everybody wrote it out correctly because it's obvious how you're going to write this matrix. Okay, so we don't need to do a lot of discussion and definition. It's obvious to everybody. It's everybody who's here that this is what you do. And if you're not here and looking at the video, it should be pretty obvious. You're going to write out matrix just as we could put brackets around this, okay? Like we did with systems of two equations last class. And then we can get rid of the x's, the y's, and the z's, and just put the numbers down. Of course, I have to put a 1z and a negative 1z, right? So we get the 1 and the negative 1. And then a dotted line indicate the equal sign, and then the numbers to the right of the equal sign, okay? It's just what we did. And by analogy, almost everybody's going to do this. Okay. Okay, so now we're going to want to do this. We're going to want to do row 1. Now, if you're making mistakes, okay, now we're going to operate on two rows at once. So we're going to do these operations. We're going to just copy down row 1. Negative 5 times row 1 plus 2 times row 2. And 2 times row 1 plus row 3. Okay. Take a couple of minutes and see if you can do that. Okay, haven't given everybody time to finish, but everybody's got at least one good step done. At least got this row. Had to check to see whether it's correct or not, but it did start with the correct number because, okay, what I did was I chose these operations because they're going to end up giving us zeros here and here. Okay. So let's write out what we get. We get 2, 3, 4, 9, just copying the first row. Now in the second row, we do negative 5 times the number in the first row. So here's in the first column, the number in the first row is 2, number in the second row is 5. We do negative 5 times 2 and 2 times 5. That's going to give us negative 10 and 10, which adds up to 0. Now you write that calculation off to the side if you like, but there it is. And everybody got that 0. And I didn't tell you I was looking for 0 there. So I assume that you're understanding. And so far, it really does appear that you are. Okay. So now we do the same thing here. Negative 5 times 3 is negative 15. 2 times negative 2 is negative 6. That's going to give us negative 21. Okay, negative 5 times 4. Negative 5 times the row 1 number in this column. Negative 5 times 4, which is negative 20. 2 times 2 is 2. Negative 20 and 2 is negative 18. Okay, then negative 5 times 9 is negative 45. 2 times 4 is 8. Negative 45 and 8 is negative 37. Okay. Now, 2 times the row 1 number is 2. looking at the first column, 2 times the row 1 number is 2, the row, 2 times the row 1 number is 2 times 2, which is 4. And the row 3 number is -4, and they add up to 0. Okay? Next, we do the second column. 2 times the row 1 number is 6. 3 times the row 2 number is 5. And that gives us 21. And that's going to be convenient because you can have these 2 rows, then we're going to get 0. Okay? In the second column. Okay, in the third column, 2 times the row 1 number is 2 times 4, which is 8. 3 times the row 2 number is -1. 8 and -1 gives us 7. And then 2 times 9 is 18. And that's just what we have. And something there looks amiss. Did I do something wrong? 8 m -1 and all that adds up to 0. I think something is wrong here. But anyhow, okay. I think that's going to bite us later, but something. Let me pause for a second because I really prefer that this works out. Okay, no, I did something wrong here. I'm checking as I go. Yeah, there's an easy way to check this, but I'm not going to give it away. Let's try the second column again. The 21 is wrong. 2 times 3 is 6. And add 5 and you get 11, not 21. Must have been unduly influenced by that 21. I don't know. I don't know why I'm making these mistakes today, but I am. Okay. So here we have it, and that's going to work out. If I do everything else right, we'll see what that happens. Okay. So I'm just going to copy this down. I'm just going to copy down row 1, row 2, row 3, just so we don't have to look from here to here to do our calculations. And I'm going to try to copy these things accurately. Using my amazing clerical skills. Not all that amazing, but they're more shaped today than usual. Okay, so there we have it. Now, you know, the next thing I want, the numbers are going to get a little messy. Rather than me telling you what to do here, well, one thing I'll do is I'll say, we're just going to copy down rows 1 and 2. Now, what I want is I want to start with 2 zeros in this row. So my question is, what numbers do we end up with here? Well, your task is going to be, the only thing that needs to change is we need to take that 11 into a 0. Okay. No, I'm sorry. Should be 0, should be a 1. What operation can we use to make that 11 into a 1 and keep a 0? What could we do to row 3? Okay, we do row 3. Wait a minute. But drainage is not particularly well oriented right now. Apparently. We really don't want to do that. We want is what I just said. We want zeros here, okay? So what could I do to make that 11 into 0 without messing with this 0? Well, I'm going to give you a hint. You're going to add a multiple of row 2, the multiple of row 3. Okay? So I didn't really leave myself room to write that. It's going to be something times row 2 plus something times row 3. Can you read that? It's not written very well. Let me write it a little better, but I'm going to pause the video because it'll be clear on the video. Little hesitation here, partly because I'm garbling things, and I do apologize for that. Why did we multiply -6 times row 1 plus 5 times row 2? It gave us 0. Why? How could we see that if we didn't know to do that, if I hadn't told you? We just look here and say, well, 6 times 5 is 30. 5 times 6 is 30, right? So I do 6 times this row and 5 times this row, I'm going to have 30 in both rows. Now I want a negative 30 in one row, so we'll make one of those negative. Okay? So that I get negative 30 and 30. Okay? I'll match up those numbers. Now what would I do? Here. Visible. It's on screen. Okay, I've got these two rows. Okay, I'm going to take a multiple of this one and a multiple of this one, and I want 0. So what multiples would I use? Just write it down. Okay, yeah, people have some trouble with this stuff, so I'm going to just tell you. And let me write it out. Here. I'm going to multiply 11 times this and 21 times this. That'll match up the numbers in these rows. That might be hard to read that. It's 11 times this plus 21 times this, because 11 times this is 11 times negative 21, right? And 21 times this is 11 times 21. When you add those, you're going to get the same thing. So you can always do this times this and this times this. Okay, this times this row and this times this row, and then put a negative sign on one of them if you need it to make it add up to 0. Now you could, oh, never mind. I want to digress to that. So at this point, we probably need to go over here. I've got to write it kind of small, but 11 times row 2. Well, it's not difficult to multiply by 11 because you multiply by 10 and just add the number. 10 times 21 is 210. Another 21 is 231. So we get negative 231. First we get 0, of course, because 11 times 0 is 0. And then we get negative 231. And then 11 times 18 is 198, so it's negative 198. And of course, you're probably going to use your calculator, which is more reliable than my brain anyway. Yeah. And 10 times 37 is 370. And another 37 is 407. So I think you're going to get negative 407. I just write out those numbers. And then I write 21 times numbers in the third row. Okay, that's easy to multiply by 21. Just multiply by 20. 20 times 11 is 220. And another 11 is 231. So that gives us 231. And then 21 times 7, 20 times 7 is 140. 21 times 7 will be 147. And then 20 times 18 is 360, and one more 18 is 368. Of course, use your calculator because it's going to be quicker and easier than me using my head. But we're going to get 0, 0. And then this is going to give us negative 51. And this is going to give us something I don't want to see. It's negative 44. Something's wrong with one of my multiplications or something. So do it with your calculator, see what I did wrong, but you're going to get a 0 here for sure. That's guaranteed if you multiply this number by 11 and this number by 21. See what the other numbers are. And these numbers should match up just a bit better. So don't know what I did wrong. I'll figure it out in my head, but use your calculator and actually do it yourself. Okay, again, this what happens. Arithmetic mistake right here. I had negative 5 times 3 is negative 15. 2 times negative 2 is negative 4. I use negative 6. It's floating in my head from another calculation. Negative 15 and negative 4 is negative 19. So that this negative 21 here should be a negative 19, making this negative 19. And now I've got to multiply these things up by slightly different numbers. So 11 times 19 is negative 190. 11 times negative 19 is negative 190, and negative 19, which is negative 9. 11 times negative 18 is negative 180, and 18 is negative 198. What I got before. Negative 11 times negative 37 is negative 407. Then 19 times 11 is 190, 290. And this has to be, since 11 times negative 19 has to be the same as 19 times 11, except opposite sign. Okay, then 11 times 7 is 77, and 11 times, 19 times 7 is 140 minus 733. And 19 times 18 is 360 minus 18, which is 342. Now, when I add these, I still get 0 here. I get negative 66 here. 65. And I get 65 here. Negative 65. So now I get negative 65 and negative 65. Now, in the next step, I want to get a 1 here. The other rows are going to be the same. So row 1 and row 2 are going to remain unchanged. what am I going to do to row 3 in order to get a 1 in this position? Okay, so I got a quick answer on that. You divide by -65. You got to divide row 3 divided by -65. And of course, that's just going to give you 0 divided by -65, 0. Same here. So you're going to get zeros. -65 divided by -65 is 1. That's why we divided by -65 to get the 1 here. And then we coincidentally have a -65 here, which is going to give us 1 here as well. Okay. Now there's more we could do. But that's going to be enough, especially since we have less than 2 minutes left in class. Okay, that's our mind running over, but I don't like to hold you and I do that too long. What does this tell us? This tells us 2x plus 3y plus 4z equals 9, and -19y minus 18z equals -37, and z equals 1. Okay. Now, since z equals 1, we can replace z in both of these equations by 1. Okay, so we can say that 2x plus 3y plus 4 times 1 equals 9, and -19y minus 18 times, parentheses in the right direction, 1 equals -37. That tells us 2x plus 3y plus 4 equals 9, and -19y minus 18 equals -37. So all I did was plug z equals 1 into both of these equations. And then I did a little very simple arithmetic. And now I have these equations, and look at the second equation. I can solve that equation for what? Just add 18 to both sides. And I'm not going to take the room because I don't have it. But I'll just say, we're going to subtract 4 from both sides. That's going to get rid of the 4 here and leave me 5 over here. And then I'm going to add 18 to both sides here. And I'm going to get -19y equals -19. If -19y equals -19, that tells me that y is 1. And then I can substitute that in here, which will give me a very simple equation that I can solve for x. So what we have here is what we call back substitution. We reduce the system to these 3 equations using matrices, or we can add rows. We can add the same multiples of equations to equations and get the same thing. Okay, we just use the matrices because they're a little more compact. Exactly the same operations with the 3 equations that we have here would have given us this. Okay, we just change it over to matrix representation, did this, and then we change it back to the equations, and we see that we have an equation. We know what z is, we can substitute for this z. That just gives us a number here, so we can find y. Then we know what y and z are, they're both 1. So we just plug that in here and solve for x. That turns out that that's okay. That's the process that we really want to focus on, with equations and with matrices. And that's really almost the last thing we do. So next week, we're going to be able to spend most of the week doing review. Okay? Very good.